Hello and welcome to Calculus Tutorial. We are taking a look at limits today, which is actually a walk backwards in the course. Most people teach limits at the beginning of calculus. I like to teach at the end of the derivative unit because historically the way limits were applied to calculus happened way after calculus was almost completely thought through. And so that's why I like it at the end. It's a slightly more historical approach. So, limits. If you're not familiar with the limits that you used in trig, let's take one quick look at why we need them. So here we have an equation, all right? And it has a domain restriction. There is one number you are not allowed to plug in because there's one rule in mathematics: you cannot divide by 0. And negative 8 makes that 0. So f at negative 8 does not exist. Okay, hopefully that looks a little familiar. From trig, that is called a domain restriction. You cannot plug in negative 8. But that doesn't mean the function doesn't get right up to negative 8, because you can plug in negative 7.9. or negative 8.01, you can get right up to negative 8. You just can't get right on top of negative 8. And so we want to answer this question. What is happening as this function gets closer and closer to negative 8? And so we can call that the limit. And the way we write it as the limit as x approaches negative 8. So what's happening as you get closer and closer to negative 8? Of this function. That we can do, but we cannot plug in the number. All right, so there's two ways we want to look at how to do this. The first way is with a table. We can simply plug in numbers and in a table, and we'll be able to see what's happening. And another way is if you're given a graph. Then you can visually see what the graph is doing or what the function is doing. Let's start with a table. Okay, so here's our function, same one, and we want the limit as x gets closer and closer to negative 8 of this function. So what we're going to do is get closer and closer to negative 8. So what are some numbers that are close to negative 8? Well, we have negative 7. That's kind of close, but not very. Let's get closer. Negative 7.9. Negative 7.99 is even closer, and then follow the pattern negative 7.999. That gets us really close to negative 8. But now we have to go to the left. What are some numbers that are just bigger, I guess smaller, just smaller than negative 8, but still really close? Well, yes, you could go all the way to negative 9, but that's pretty far. Get closer to negative 8. Not 9.1, that'd be farther away. So let's go negative 8.1. That is just barely bigger than negative 8. But get closer. Negative 8.01. So that's like $8.10. That's $8.01. Get even closer. 8.001 is right next to negative 8. All right, so those are the x values we're going to look at because we can plug in all of these numbers. We just can't plug in that number. So we're just going to type those into our calculator and see what it gives us. All right, I think my equation is slightly wrong here. Here, I'll just do it from the beginning. There we go. So, put your fraction bar. On the top we have x squared plus 6x minus 16 on top. And on the bottom, x plus 8. Alright, so there's our equation. Now go to numerical view right here for our table. And we're going to plug them. I got a few of them in already. Negative 9, negative 8.1, negative 8.01, and 0.001. So we've got negative 11. Bring it back up here. Negative 10.1, negative 10.01, and negative 10.001. All right, now let's do the others. So we've got negative, oops, let me pull up my, negative 7.9, negative 7.99, and negative 7.999. Well, I think I did want just plain on negative 7, didn't I? All right, so what do we have there? So this one was negative 9.999. This one I think had 2 9s. This one had 1 9. I think that was just plain old negative 9. So as we come this way, and as we come this way, I'm hoping you can see what number kind of, sort of, should be right here. Negative 10. So the limit as x gets closer to negative 8 is equal to negative 10. Now, can you actually plug in negative 8 and get 10? No, because then you will get 0 in the denominator, and that is not good. But the limit as you get closer is equal to negative 10. All right, so that's how you can do that with a table. What about with a graph? So here we have a function, and we're going to take a look at some interesting limits with this. There's lots that you could do any limit you wanted to. So an uninteresting one would be the limit, say, maybe as x approaches 0. Nothing weird is happening. Oh, let's call this h of x, huh? This one would be a fairly uninteresting limit because there's nothing weird happening right here at 0. Our function is coming down this way or up this way. And so what number are we getting closer and closer to? 3. Okay. But there are some slightly more interesting ones. I would say this is a more interesting limit because we're going from a linear to a quadratic. So as I come this way on the linear, and as I come this way on the quadratic, I'm getting closer and closer to 1 of my function. What number are we getting closer and closer to? Well, the arrows do in fact line up here right at 2. All right, one more. Well, actually 3 more, sorry. So the limit, another interesting one, will be when we get closer and closer to 3 of our function. So if we go from the left side and we follow up, we're coming all the way up to 6. But if we follow from the right side, we're coming to 3. They're different, and so the limit does not exist. It's not the same coming from the left and from the right. The limit does not exist. And so what you can do there is you break this up into 2 limits. The first limit, as x approaches 3, and what you say is you're from the left. And the way you call that is you put a little minus sign up here in the exponent. That means you're approaching 3 from the left. Think of negative numbers as being on the left side. And so what number are we getting closer and closer to on the left? That was up here at 6. And if we do the other one, the limit as x approaches 3, but we're coming from the right side and think positive numbers are on the right side. So we put a little plus there. That means we're coming from the right. What number are we coming to from there? 3. So you can break it up into two smaller limits, from the left and from the right, but if they are not the same, then your limit does not exist. Okay? And so we didn't have to do that over here because the two arrows were matching, but over here the two arrows were not matching. All right, that's a quick crash course for limits, and we are going to continue applying that to our calculus ideas in a few more days.